Hello everyone, this is Prashanto Boiragi, Assistant Professor, Computer Science and Engineering, Assam Downtown University. Today, I am going to discuss a very common topic of software engineering, simply known as a software testing. Although it is a very common one, but it is one of the most important phases of software development because it determines whether the software is eligible for use or not. Okay, let's start the presentation. These are the contents of my presentation. We're discussing some basic points of software testing, including its definition, then objective of testing, goals of testing, testing methodologies, and conclusion. In this presentation, I am not going to discuss the software testing in details. I simply try to give a basic idea about software testing. Okay, what is a software testing? Basically, a software testing is a process of verifying and validating that a software or application is bug-free, meets the technical requirements as guided by its design and development, and meets the user requirements effectively and efficiently with handling all the exception and boundary cases. So basically, software testing is a process to determine whether the software is able to meet all the requirements in every aspect, because the software testing is a phase of software development and which comes at the end of the development, when the development is already done and that we have to check whether the software is able to meet the requirements or not. And for testing the requirements or testing whether the software meets the requirements or not, we have two basic techniques. One is called verification and second one is called validation. These two processes simply highlight whether the software meets all its requirements or not. Again, the process of software testing is not only limited to verifying whether it meets all its requirements or not. It is also a process to upgrade the quality of the software, because when we are doing the software testing, the first things we are doing that we are checking whether there is any error or not, or whether the software meets all its requirements or not. If no, if there are some errors, we simply try to correct them. But if the software or somehow the software meets all its requirements, then what next? Then we are trying to find out, is there any better way to do the same thing so that we can improvise the quality of the software. whenever we are dealing with a product, we have to maximize its capability. Otherwise, there is no point of developing any product. So that's why the process of software testing aims not only to find its fault in existing software, but also to find the measures of improving the software in terms of efficiency, in terms of accuracy, and in terms of usability. Because when we measure some softwares, we have some key points, whether it is efficient, whether it is accurate, or whether it is easy to use. These are some factors which determines the quality of the software. This is something basic about software testing. The next is objectives of testing. So we have already discussed something about software testing. So apart from this, there are some main objectives, and there are some other objectives also, like uncover as many as errors or bugs as possible in the given product. So that means whenever we are doing some testing, we are trying to find out more errors so that we can solve them and make the product more error free. If we go for some basics errors, and we are assuming that the product is ready, but when we are going to use it in a practical life, the possibilities of occurring error is high. That's why at the time of development, in the particular testing phase, if we are trying to find out or extract as many as errors we can, that means later the possibilities of occurring error is very less. And second point, demonstrate a given software product matching its requirements specification. Because whenever we are going for a software development, we have to follow some specific component like software requirement specification document, and this document is the key document of any software development. That means anything we are going to do with a software, whether it is designing, whether it is coding, whether it is testing, everything is based on this document. And in software testing, we are going to demonstrate whether the software, or whether during the development of the software the developer strictly follow it or not, so that in later when the user is going to use it, he or she will not face any kind of problem. The third point is validate the quality of a software testing using minimum cost and effort. The third point, it is another important point of software testing, because everything is related to software quality. Not only about the software, quality matters everywhere. When you buy any clothes, whenever you buy any kind of product, the first thing comes in our mind that what is the quality of this product. And simultaneously, second thing comes into our mind is what is the cost of this product. That means we need high quality with a low cost, but sometimes it is not possible. So that's why we have to do some testing so that we can enhance the quality of the software by minimizing the cost and effort. Because if we invest a huge amount of cost and efforts in the development of a particular software, we cannot minimize the price of the software, and it gives a negative impact to the software. The last one is generate high quality test cases, perform effective test, and issue correct and helpful problem report. So basically all the test cases or all the testing, whether we are go for any kind of testing, there are different kind of testing. In every testing, the main motive is to generate a quality product. And for generating a quality product, the testing performs a major role. That means in every step we have to do the testing so that the end product comprises of less error. And for this we have to design a lots of test cases so that the overall testing can be done more efficiently. For example, suppose you are designing a calculator and basic calculator, and you are testing whether the addition, subtraction, multiplication and division performs well or not. The simple thing, you give a input of 5 plus 5, it gives 10. That means your addition operations work perfectly. But if we see the test cases is very basic, maybe this system can capable of performing well in basic cases. So that's why we have to do more, or we have to run more test cases to validate whether the addition operation performs well or not. And for this we have to design more test cases. Suppose we have to consider huge number to perform the addition operation, or we have to consider decimal number to check whether the same addition operation perform it or not. So these are some points, or these are some objectives of software testing to enable the product, to make the product, actually to make the product as a, or to design a product, or to design a good product. The next comes to errors, bug, fault and failure. The first one is error. What is the error? If you are trying to do something and you are unable to get the results, there is an error. But in computer science, or in terms of software testing, we can divide the types of errors into different categories. The first one is, suppose, error. So it is a human action that produce the incorrect result, that produce a fault. If the reason of generating a fault by human intervention, suppose you are giving wrong input, you are doing some mistakes while we are designing the software, the error made by the humans, this kind of errors are this kind of actions are considered as an error. Then bug, the presence of error at the time of execution of the software. That means when you execute a software and it shows error, this is called bug. And we can identify, or we can term these two types of error in two different ways. Like suppose the first one, errors, can be termed as a syntax error. That means anything wrong written by the developer or human. And the bug can be considered as a semantic error. That means errors occurs during the execution of the software. Then the third one is fault, state of software caused by an error. That means in this category, the state, that means at what point the software is executing right now, maybe this is the result of an error. That is the state of the software. Then the finally failure, the deviation of the software from its expected result, it is an event. That means you are expecting something, but you got something else, it is considered as a failure. That means you can reach the end, but at the end whatever you have in your hand, it is not you are expecting. Throughout the journey you are able to complete the journey, but at the end whatever comes in your hand is not what you are expecting. This is called failure. Then goals of testing. So there are different and goals, and this is somehow similar to objectives or aims. The goals are like detect faults, establish confidence in software. That means as much as you do the testing, you build the confidence that the software will perform well. Then evaluate properties of softwares, because as I mentioned earlier, there are some properties based on which we can consider a software whether it is a good software, average software or bad software. And software testing is the process of evaluating this kind of properties, like reliability, whether the software is reliable or not. That means whether we can trust the software or not. Like suppose calculator, we input data and whatever results we will get, we trust blindly that the calculator is giving us the correct result. Performance, whether the software can perform well. Memory uses, whether or how much memory it requires, because if the software is very good but it requires a lot of memory, we are unable to use it, because memory is one of the major concern of any storage. Then security, whether it is secure or not. We are sharing so much information with the particular software, whether it is secure or not. Then usability, that means what is the user interface of the software, what is the complexity of the software. These kind of things we can evaluate during the testing process. Then testing methodologies. So till now we have discussed what is testing, what are its objective, what are its goal, but how we can perform testing, or what are the types of testing we have to determine the properties of the software, to determine whether the software is good enough for use or not. Okay, we have two basic testing methodology. One is called Whitebox testing, the another is called Blackbox testing. That means whenever we have or whenever we develop a product and we are going for the testing purpose, we adopt Whitebox or Blackbox. Sometimes we go for Whitebox, sometimes we go for Blackbox, or sometimes we have to use both of them depending on the complexity of the software. That means what kind of software we are developing. Now, what is Whitebox testing? The Whitebox testing is a testing where knowledge of the internal program design and code required. That means when you are going to test a software, there are different peoples who can be associated in the testing process. Sometimes from the developer team, sometimes from the outsider. Okay, that means if a person is performing the testing operation and he belongs to the developer team, he or she will aware of the internal component of the software. That means how it works, what are the technology we are using, etc., etc. And in Whitebox testing, it is mandatory that the person who are performing the testing must know about the internal program design and code. so that while testing, if necessary, he or she can do any kind of modification. Then tests are based on coverage of code, statement, branches, path and condition. That means if someone is aware of the internal component of the software, then only he or she can perform the white box testing. These are two basic requirements of white box testing. Then similarly in black box testing, no knowledge of internal program design or code required. That means the user can also verify whether the software meets his or her requirement or not, or any person in that organization who is not associated in the development of the software also can perform the testing, because no internal details required during the testing. Tests are based on requirements and functionalities. That means everything is listed earlier. What are the requirements given by the user, and based on what the developer develops it. So simply in black box testing, the tester have to check whether it meets the mentioned requirements or not. That means white box and black box testing can be done by two different categories of people. In one category, the testing people should aware of the internal design, internal component of the software. In the other category, anyone can perform the testing based on the requirements listed earlier. Then difference between white box testing and black box testing. So in the earlier slide already we have discussed what is white box and what are its requirements, what is black box and what are its requirements. So basically the basic difference between white box and black box is that in white box, internal working of an applications are not required. That means internal knowledge is not required while performing the testing operation. Simultaneously in white box it is required. Knowledge of internal working is must. That means if you are not aware of the internal component of the software, you cannot perform the white box testing, but you can go for the black box one. Similarly, also known as a closed box or data driven testing. That means what is data driven? That means everything is based on some data. You give some data, you get the result. You give another data, you get another result. In white box testing, known as a structural testing, that means step by step testing. In this particular position, you perform some testing, you get the result. Then go for the next portion. Then go for the next portion, because you are familiar with the internal structure of the system. In black box testing is also considered as a end user, testers and developers. That means when we completed the whole development and able to generate the product, then we go for the black box testing. That means end user. But in case of white box testing, normally done by the testers and developers, because testers are those people who are aware of the internal component of the thing, of the product. Similarly, developers are the portion of the people who are directly associated with the development of the software. They are aware of it, and therefore they can perform the white box testing. But in black box testing. But in case of black box testing, apart from these two, the end user also able to do it. So that means it is clear that in black box testing, the testers and the developers can perform the testing operation, and apart from this, the end user also can. But in case of white box testing, end user cannot perform the test because he or she does not have any internal knowledge of the particular software. And in black box testing, this can only be done by trial and error method, because this can be done at the end of the software product. That's why it is a trial and error method. You do the trial, give an error, report them. In case of Whitebox, data domains and internal boundaries can be better tested. In case of Whitebox testing, since it is not an end user or end product testing, this can be done within the software in an internal way. In every steps we can perform the testing operations. Either it is an internal or in the boundary of the software. Okay. In the conclusion part, here I am not going to discuss anything else on software engineering. But whatever we have discussed till now, the basics of software testing, what is the definition, what are its objectives, what are its goals, what are the basic methodologies we have, and who are the persons who can associate it in the testing process. So at the end, we can say that the testing is one of the most important phases of a software development, because once it verified during the testing phase, then only the product can be usable. If the product is not able to fit in the test cases in any point or in any aspects, the softwares are not, or no one is going to use this software. So in the conclusion, we can say that in order to be cost effective, the testing must be concentrated on areas where it will be most effective. That means in most of the testing, we have to give effort in every areas, or most of the test cases should be designed in such a way that it covers all aspects of the software. The testing should be planned such that when testing is stopped for whatever reason, the most effective testing in the time allotted has already been done. So that means we have to design the whole testing mechanism in such a way that depending on the state of the software, depending on at what state the development is, based on this state, a suitable testing technique should be allocated to the software. Then the last one is the absence of an organizational testing policy may result in too much effort and money will be spent on testing, attempting to achieve a level of quality that is impossible or unnecessary. So that means it's not like that. If we give more effort on testing, if we invest more money, more time on testing, we are able to develop a good product. It is not true. That means the approach is very much important, and the approach is depend on what kind of softwares you are going to develop. If you are going for a complex one, then you have to do a different kind of approach which can meet all its requirements. Similarly, if we go for a simpler one, don't wasting time and money by going the complex approach. Design a simple one. But in both cases, you have to keep in mind that both should be effective. Both should be effective in terms of evaluating the quality of the software, because at the end quality matters. If the quality is good, then the software is good. If the quality is not good, the software is not good. Okay. This is all about software testing. Thank you.